Hello and welcome back to my series on contemporary mathematics. This is going to be a video on section 6.6, methods of savings. Again, this is going to be a little bit different than what I've done in my previous videos where I've used the PowerPoint slides. I'm going to kind of walk through the textbook so that I can flip back and forth to this TVM, which stands for Time Value of Money Calculator. So for section 6.6, we're talking about the methods of savings. So our objectives are to distinguish between various basic forms of savings plans, compute return on investments for basic forms of savings, and compute the payment to reach a financial goal. So let's just jump down because you're going to read this and you're going to, get this information. But there are various basic forms of savings plans. There's a traditional savings account. This is considered a deposit account. Money is going into the account. That is your money. Typically, it is secured by what's called the FDIC, the Federal Deposit Insurance Corporation. This is an account sort of that the federal government has that is kind of seeded by fees that are paid on things, and so it's not actual quote-unquote tax money that funds the FDIC. When banks have to pay fees, a portion of those fees have to go to the FDIC, and those fees are then distributed so that there's kind of this insurance that backs deposits up to $250,000. What's interesting is not recently, when this recording happened in 2003. I'm recording this in 2003, and so in this year we had several major multi-billion-dollar banks crash, and deposits from the FDIC they actually raised the bar and secured all the deposits from those, including multi-million-dollar accounts, which is a little different. That actually goes kind of against their policy of, the $250,000 kind of bond or trust that's there. So, typically it's what is now realized is that this is sort of a lower bound rather than an upper bound. This is kind of what we shoot for with FDIC insurance, but excuse me, counts that have more than that, if the federal government thinks that's going to stop a major economic collapse, they apparently have some wiggle room with that, which we found out in 2023. So what we have, let's look at an example of what's called a single deposit account, which means that you put money into this account one time, single deposit, and you leave it there, and then it just gains interest. So in our previous lecture in section 6.4, where we talked about compound interest, we talked about things being compounded monthly or annually. Well, we're going to go back to that concept here and look at, if we're saving money, what are we going to have with like a single deposit account? So let's look at this example. We've got $4,500, or let me look at it again. I'm sorry, $4,520. Yep, at 1.42, I believe, 45%, compounded annually. And this is Violet, and she does not add or withdraw any money to that. So we're going to consider that a negative. So she had to put that money in there, and she's going to pay nothing else. In other words, she's not going to deposit any money, nor is she going to withdraw any money. Compounded annually for 3 years. So she's going to have 3 periods. Annually is one time a year for 3 years, so that's going to be 3 interest payments. So if we calculate the future value, Violet should expect to have $4,719.48 in that account. Now, if you look at the answer from this example, they do use the formula, which the rate was that 1.45% written as a decimal, and then divided by 100 because it was annually, multiplied by 3. And so that gives us the same answer as what we had there. And so you can see that over those 3 years, she's gained this amount. She will have this amount. She's gained, a little, right at $200 or something. So again, I love these your turn. So, I've done this one problem. You can try it by the formula if that's what your instructor is. If you're in my class, I highly advise you head on over and use the TVM calculator, but pause the video and try your turn 6.55. See if you can get the answer, and you can click this number beside it and it'll take you to the solution for your turn 6.55. So we're going to go ahead and move right along. We also have a type of savings account called a certificate of deposit, which is CD for short. These aren't really as popular as they used to be, mainly because they're a little more restrictive. I'll talk about that in a minute. And they don't offer as high yields as they once did historically. So certificate of deposits literally used to be a certificate. They would print you out a piece of paper. So you'd walk into a bank, you'd have like $5,000 in cash. You'd hand them the $5,000 and they would hand you this certificate to say, you're going to leave your money with us for, anywhere from 6 months to 5 years, and you're not going to withdraw it. And you can't withdraw it. And if you do withdraw it, you're going to be penalized. You're going to have a percentage of your money taken from you instead of given to you. And so it was kind of like, for banks, it was a bit of an insurance policy. The federal government calls it a bond. The bank called it a certificate of deposit. So with that, they were insured by the FDIC, but there wasn't this flexibility of being able to easily get to your money without being punished. Like, you went into the bank knowing that when you put in the money into the CD, you were not going to be able to get it out unless you were willing to take less than what you invested, which is bad. Otherwise, you should just take out a loan. That's basically what you're doing. But, you're doing worse than a loan, because you're just losing straight up money and not getting anything really in return. So let's say that you had a 5-year CD. So you walked into, so let's say Silvio here has $10,000. They're going to walk into a bank. The bank is going to give them a CD that yields 2.17%, compounded semi-annually for 5 years. So that's going to basically be 10 interest payments on $10,000. So with that, because it's a CD, Silvio cannot touch it. So 2.17. Cannot touch it for 5 years. So it's compounded semi-annually. That's 2 twice a year. So 5 times 2 is 10. It's not going to withdraw any money because that's a penalty. You can't add any more money to it. It's kind of like a static account. But you can see that Silvio is going to get some gains off of that. They're going to gain $1,139.54. And so you can kind of see here that that's what happens. If you do the formula, you get the same thing, but we see here that for 5 years worth of investment to get $1,000 or $1,200, it's not bad. It's not great. Depends on if you've got $10,000 that you can just watch go and then let it sit. So that's kind of the idea between a CD that's mentioned up here. But just to give you an idea that if you're looking at saving some money, and you've got a good chunk of change, and you're able to not touch it, you can just let it sit. There are some CDs out there that are higher yield, 3-4%, but you have to go in knowing that you're not going to be able to touch that money unless you're willing to take it out at a penalty. Other savings accounts that are long-term, so CDs are short-term, relatively speaking. 5 years is not that long in financial world. Long-term savings accounts like IRAs, which are individual retirement accounts, those are for many, many years. Typically, you're talking about 20 years of savings. Those also have fees associated with withdrawing, and depending on the type of account that's withdrawn, if it's a traditional IRA, you're going to have to, if you withdraw early, which means before you retire, because it's an individual retirement account, you're going to have to pay state and federal tax and fees. So IRAs can be heavily penalized if you do not wait until retirement. So you only want to put money in an IRA and a CD that you are comfortable not seeing until the end, which is called the maturation date, when the loan matures. So again, there's a your turn for that. I highly advise you check that out. Another type of savings account is something called a money market account. Money market accounts are very common. Employee or credit unions, the state employees credit union in North Carolina and Tennessee and Georgia, that it has one. Money market accounts. They're kind of interesting because a lot of money market accounts can also act like a debit account. And so it has the ability to allow you to write checks and have a debit card kind of associated with it, but you also gain interest rate on having it. And so just to give you a little personal information, like I'm from North Carolina, so I have a North Carolina credit union or state employees credit union account. That kind of works. They call them share accounts, so money market share accounts, kind of the same thing in that realm. But when I got married, my wife had taught in Hawaii, and so she has a credit union account that is a traditional money market account. And so it earns 5% interest at the time of recording, which is significantly higher than most other money market accounts, and anything higher than I have at the state that we have if you're a state employee at the state employees credit union. So money markets are good because they act kind of like a two-parter. They are both they can act sort of as your checking account. You can write checks out of them. You can use an ATM card. But they also earn interest, which is rare. Checking accounts, like traditional pure checking accounts, absolutely do not. Sorry about that. I have a tickle in my throat. So let's look at Marietta. She opens a money market account, deposits $2,500, and it's going to bear 1.76% interest compounded monthly. So if she makes no other transactions on the account, how much will she have in 4 years? This is a math textbook type problem. This is not a real world problem. If you have a money market, a lot of times you're moving money into it and out of it. It's a very dynamic account, but just for the sake of this math and how to use the TVM calculator, let's look at how that works. So again, we've got a deposit of $2,500 at a rate of, I think it was 1.76%. Yep. Now it's compounded monthly for 4 years. So again, if I bring up my calculator here, just to show you, we're talking about monthly, so 12 times 4, so you're looking at 48 periods, and we got to change our compoundings to monthly. Now, no other transactions means payments is 0, and then how much is the future value? So you're looking at $2,600, so $2,682.20 gained on that account. So a little over $100, just so you can see it, that our answer matches, the book. But a little over $100 for 4 years. It's free money if you think about it like that, but you're not, not getting rich quick with something like this. Now, if you had a lot more money to invest, of course, then you're talking about, $10,000. If you've got 100 times the amount to invest, then you're looking at 100 times the amount to gain. But the smaller the amount, kind of the smaller the gains. And, it's kind of how the game plays. So free money is free money, right? $100 for 4 years. But, is there some other way, or is there a better saving option? Well, yeah, if you have more money with a higher interest, that's going to be better. So there is something called the return on the investment. I don't have any questions on this. You can look at it. So ROI is return on the investment. That's the percent difference between the initial investment and the final investment. If it's a positive number, then that means you had a positive return on investment. So the higher the percentage and it's positive, the better the investment. If it's lower, like closer to 0, that means it wasn't a very good ROI. If it's negative, that was a bad ROI. So, kind of in that regard. So length of time of the investment is not considered in ROI. So you kind of have that. So you can look at these examples of ROI. You just take the future value minus the present value and divide it by the present value. So we're talking about a 12.39% or 12.4% 12% return on investment. That's not that bad. That means you got a 12% increase basically in what you were doing. But in this case, we were given the future value, so we don't know like what the interest rate was. We could probably solve it since it was 5 years. We also don't know how many times it was compounded. So there's a lot of information missing on this to really compare. But you can kind of see that if you were comparing these two investments, the first investment is better than the second investment only because the return on investment in the first one is higher than the return on investment in the second one. And that's kind of so you can compare apples to oranges. Like you don't know anything about these two other than one's a 5-year CD and one's a money market. So the return on investment for the CD was greater than that of the money market. So you're better investing in the money market. But I would argue that, well, they invested $10,000 compared to $2,500. So there's lots of things to consider here, but pure numbers wise, the CD here is a better return on investment simply because its ROI is higher. So you can watch this video on return on investment. That'll probably enlighten you a little more, but that's really all I want to say on ROI. What I would like to get to is annuities as savings. So annuities, you've seen those commercials, the J.G. Wentworth commercials. It's your money. Use it when you need it. They talk about annuities. So that's a type of savings account that's going to pay you regular payments, or you're going to make payments at regular intervals into it. So when we talk about an ordinary annuity, the future value is given by this formula. Of course, you can read it and you can see it, and that's there for you. But I'm going to show you how to do this in the TVM calculator, much easier. So let's look at this example. So Jill has an account that bears 3.75% compounded monthly. So she decides to deposit $250 each month at the end of the compounding period. So we're kind of assuming that it's compounded monthly. So at the end of each month is the compounded period into this account. What's the future value of this account after 8 years? So let's assume that from this, Jill has put nothing into the account. So let's start from scratch. Let's say that the present value of the account's 0. She's getting 8%. She's taking from her available money, so we're going to make it negative, $250 a month. And it is, the rate is 3.75. It's 8 years compounded monthly. So let's grab the calculator, 8 years compounded monthly. So we're looking at 96 periods compounded monthly. So how much would she have in the future making these payments? Should have $27,938.20. And so that's exactly what we're going to get by doing that formula, because what's happening is every month she's going to add $250 into this account. Well, that $250 that first month is going to get interest, and then that's going to happen, and then it's going to get interest every month. It's called the snowball effect. So every little bit of interest is then going to gain interest until it snowballs from $250 a month, that after 8 years, she's accumulated $27,938.20. So, if you wanted to save for a car, and you have a car that's about $28,000 and you want to save for it, putting away about $250 a month in an account that pays 3.75%, which they're not easy to find, but they're not hard either. They're out there. You can have $28,000 saved, but you've got to be willing to. The hardest part about this in this savings scenario is putting the money away and not touching it. That is the hardest thing about these savings accounts. So that's just kind of how we put it in there. Again, the present value is nothing. We assume that she started with, this was Jill, yeah. We assume Jill started with nothing. She's paying 3.75% interest. She's getting paid 3.75% interest. She's paying $250 a month. 8 years times 12 is 96, so that's given her about that $28,000 in savings. You can use the formula, of course. I'm not going to stop you, but plugging that in, if your teacher requires it, of course, then you've got to. But if you're in my math class, I want you to use a TVM calculator so that you get to the numbers rather than getting kind of lost in this algebra here. So again, here's the your turn 6.59. I highly advise you stop this video right now and try it. It's a little tricky because it talks about investing every third month. Well, think about that. If you divide 12 by 3, that's 4. So you're really talking about every quarter, and it's bearing interest, compounding quarterly. So I would stop and try this one, knowing that every third month is really talking about at the end of the quarter. All right, so let's continue on. So let's talk about maybe some examples. They've got this text stuff. I don't really use Google Sheets. Google Sheets is the same thing as the TVM calculator. But what I want to get down to is computing payments to reach a financial goal. Because one day I want to retire, and maybe you want to retire, or maybe like you want to save for a car, like we're going to see in the next example. And you want to know, like, I want to buy a car for this much. How much do I need to save? So let's look at this example. I think that's Yaroslava wants to save in order to buy a car in 3 years. So she determines that she'll need $35,500. So this is either going to be, I would hope that this is her estimate based on, taxes, tags, title, all that stuff. So we want to know how much does she need to deposit into an account in order to achieve this financial goal. We can still do all that with the TVM calculator. There, of course, is a formula for payments. It's right here on the screen. That's the formula for payments. But we can do this with the TVM calculator. Oops, I don't want to show that just yet. So we start with this amount. So this is actually the future value, because this is what Yaroslava wants to have after 3 years. So this is actually our future value. So let's refresh. So we're starting new. So 35.5. So 35.5. She has an interest abearance of 4.25%. It's going to be 3 years compounded monthly. So we're talking about 36 months is how long she has to save. Let's assume that she starts with nothing. She currently has nothing saved. How much is she going to have to pay every month? So in order to achieve this goal, in order to have $35,500 in 3 years, compounded monthly at 4.25%, she's going to have to deposit $926.32 into an account and not touch it. Every month and not touch it. Right? And so if we look, that's what they get here. So in order to reach her goal, she is going to have to deposit that amount every month and make sure that she doesn't touch it. If she does, it kind of resets the clock a little and kind of adjusts the goal. So you can kind of see that this has been rounded up so the deposits don't fall short of the goal. However, some rounding, could be off a little. And it really depends. I would advise that if you're saying how much do I need to put in, I would always round up or put in a little more. It's better to overshoot a financial goal than to undershoot it. Maybe even the same thing with loans. Like when you calculate a loan payment and you go and, it says, this mortgage is going to be $853.27 a month. Just round up to the next dollar. Pay the few extra pennies. It actually could end up knocking off a month or two from your overall in the end. But just make sure that you're wary and careful about, rounding stuff. As far as the online homework, I've put in a buffer into the software so that, you have some leeway in the pennies there. So let's go down to some examples real quick. Let's talk about Ashley here. They want to save for early retirement. She thinks that she needs about $1,250,000 to retire at the age of 55, which is 30 years from now. So she's 25 and she wants to retire at 55. So how much must she deposit per month in an account bearing 3.48% interest compounded monthly in order to reach her goal? So let's look at how we could help Ashley here calculate this. So Ashley wants to have 2.25 million, which is $1,250,000 in 30 years. Let me highlight this so when I keep coming back to it, I know what I'm looking at. So in 30 years, so 30 times 12 is 360 at a rate of 3.48%. Yes, 3.48%. Now, let's say that Ashley right now, age 25, has no savings whatsoever. Let's hit that payment button. Oh, see what I did? That's saying 360 years. We got to change it to monthly, and that drastically changes it. So what this is saying is, if we were Ashley's financial advisor or a friend or something, and we said, "Hey, Ashley, if that's really how you want to retire, if you think you need $1.25 million, which is actually not far from the truth anymore, you're going to need to deposit about $1,974.11 to meet that exact goal." So, maybe round up just in case. So, that's kind of how that works. So again, just looking at this is how much she needs in the future. So that's the future value. And then 30 years from now, compounded monthly, just to show you, I've done this so many times that I just know it, but 30 times 12 is 360. It's just kind of ingrained in my brain at this point. So that's it. I'm going to go a little off the cuff. This isn't from the book, but I just want to show you, let's say that when you're in retirement, right? Let's say that you're in retirement and you want to be able to live off maybe $2,500 a month. And you've got an account, let's say it's generous, paying you 3%. Now, most people retire at 65, and most people, nowadays live to about 80. So let's say 80 minus 65, you're talking about 15 years of retirement. So multiply that by 12. So you're looking at 180 months from the time you retire till the time you kind of expire. I hate to rhyme and be kind of morbid, but what we're talking about here is from the moment you retire at 65 until you eventually pass away. Life expectancy is about 80. So you're looking at about 180 months of retirement. How much money would you need to save in order to meet this goal of, pulling out money every month? Well, then you need to have $362,013.68. So what this means is if I could save $362,013.68 by the time I retire, and I can find an account that pays me 3% interest, then I can withdraw 180 months worth of paychecks at $250, and my future value would be $0. So that's kind of this backwards work. What if I want to pay myself, which is what I'm doing here, what if I want to pay myself $2,500, $2,500 a month for 180 months at 3% interest? Well, I can do it with this account. Another kind of hypothetical scenario is, let's say that you won $1 million in the lottery. You got $1 million, right? And you set it up in the same account. And let's say that, you wanted to retire today. I don't know how old you are, but, I'll just give you a hypothetical. Say that, somebody's 35 years old. I'm not 35, but let's just say 35. Somebody's living to 80 years old again, minus 35, retired today. So they got 45 years left, 12 months to, ignore that 6, ignore that one. So 540 months from 35 to 80. How much could they get each month from $1 million? So if you took that $1 million winnings from the lottery or wherever, put it in an account earning 3%, what this is saying is you could withdraw $3,376.91 a month for 540 months, and you would drain the account in 540 months. So basically, that's a $3,300 paycheck a month that you could live off of $1 million. So when people wonder, like, how do people retire so young? Well, you know, if you're young and you can save, for example, $1 million, or even better, $2 million, then what you end up being able to do is pay yourself $6,000 a month, $6,700 in this case, you know, until you die. And most people can live off $6,700 a month. If not, and they're successful, then they can just keep, you know, make a few extra money, or, you know, a few extra million. So, you know, somebody makes $3 million, just sets that money aside, and wanted to only live off the interest, then we see here on the screen that they can pay themselves $10,000 a month. $10,000 a month for 540 months, and then they would finally deplete that account. And so, you know, that's just kind of the math behind people who we think of as, you know, wealthy, and, you know, how do they sustain? Well, in order to deplete their money, they're having to, because they're having interest work in their favor, they're letting their money make money. They are allowed to sustain themselves, and they're living. But, you know, anyway, I don't want to go on a rant. I just wanted to show you some interesting problems and how you can kind of use this. So that's really all I have for section 6.6 about savings. So what I want you to do now is, you've watched the video. I want you to go back, read the textbook if you haven't done so already. Take those handwritten notes, work on those your turn problems, make sure that you're able to answer those. Answers are linked and available at the end of the section. And then head on over to the LMS and work on the homework for section 6.6 to reinforce your learning.